How are gigantic ship propellers made? Many large propellers are actually a single piece of bronze alloy. They are formed by casting the entire propeller in one go. In casting, you pour molten metal into a mold. Let the metal cool, and out pops a solid metal part. Why ship propeller is made from bronze? Bronze has a strong resistance to corrosion, particularly in marine environments. Bronze is resistant to corrosion cracking from chloride heat. It all renders bronze suitable for usage in the marine setting. How long does it take to make a ship propeller? Once a design has been selected, the molten metal is put into the mold and left to cool. The propeller is so massive that the metal takes a full 5 days to cool and harden. Building a large ship requires a massive amount of engineering work. Even the smallest parts require lots of time and effort to design and build. Case in point, the ship's propeller. The prop has to hold up to millions of miles of travel and move the ship fast enough to get from port to port in time. In this case, the propeller is cast in one piece and is made of a complex alloy involving 8 different metals. Long before the actual casting process has been started, the propeller had to be designed. Dozens of variables have to be accounted for to design the most efficient propeller possible. A poorly designed propeller can lead to poor fuel efficiency or low top speeds, and even reduce the lifespan of other ship components. Once a design has been selected, the molten metal is poured into the mold and left to cool. The propeller is so massive that the metal takes a full 5 days to cool and harden. Once the metal has cooled, the mold is broken off and the propeller is sent to the milling machine. The machine is computer controlled and spends the next 15 days polishing the propeller. After almost 3 weeks of production, the propeller is finally ready to be attached onto the ship. All that work for just a single component on a massive tanker. Marine propeller is a rotating fan-like structure which comprises radiating blades and propeller shaft. It is utilized to propel a ship with aid of power generated by main engine of ship. The propeller produces thrust, which is transferred through transmission system of ship, resulting in movement of the ship. Marine propellers are manufactured using corrosion-resistant materials, such as aluminum and stainless steel, which possess the ability to operate efficiently in seawater. A marine propeller can be 2-bladed, 3-bladed, 4-bladed, or 5-bladed, based on speed of the ship. Growth of the global marine propeller market is driven by greater adoption of electric propulsion technology, increase in new shipbuilding and repair activities, greater demand for sea-based logistics and trade, and growth in demand for marine travel and tourism activities. However, high maintenance costs and introduction of strengthened environmental regulations are factors that restrain growth of the market. Furthermore, technological innovations in marine propulsion systems and growth in Navy expenditure across the world are factors expected to offer growth opportunities during the forecast period. The global marine propeller market is segmented on the basis of type, material, number of blades, application, sales channel, and region. On the basis of type, it is classified into fixed pitch propeller, controllable pitch propeller, and others. By material, it is fragmented into aluminum, stainless steel, and others. By application, it is analyzed across merchant ships, naval ships, recreational boats, and others. On the basis of sales channel, it is classified into original equipment manufacturers and aftermarket. Increase in demand for alternative propulsion systems, owing to climate changes, has resulted in introduction of electrical propulsion technology. Electric propulsion technology aids in reducing carbon footprints as well as increases overall efficiency of ships. Moreover, several manufacturers have been developing electric propulsion systems to be integrated in new ships to reduce carbon footprint. For instance, introduction electric propulsion systems for cruise and ferry applications. The layout is done first and most important part of the job. It shows cross sections of the blades at chosen points. This includes the anchor, rake, thickness, machining allowance, length and shrinkage allowance for the metal casting process. After the general layout is complete, material requirement calculation made for the construction of the propeller. It is important that the wood or metal be clear of knots, as a lot of carving is involved in the shaping process. For these propellers, 19 layers were used for each. A separate layout is then generated of the original layout to determine shape of the individual cans. Once both layouts have been completed and checked, then checked again, construction can begin. Mold patterning. Pitch plates are necessary in sand mold patterning to scrub the spare surface. Its accuracy may directly affect the completed quality of the blades. To determine the sizes of the pitch plates, factory will consider the pitch of the blades and also the casting material shrinkage after pouring, bench thickness and the propeller geometric characteristics. Mold casting. Factory use clap sand mold to cast the propellers. The propeller face lies under the mold and the propeller backside lies above. In the sand molding, the first of the triangular pitch plate to complete the appropriate cylindrical surface, and then use the scraper along the axis of the set of helix plate, obliquely scraping the surface of the spiral surface. Only a scraper is needed for equivalent pitch blades. The radial linear variable pitch by pitch changes to add a pair of scraper. Melted alloy will be cast into the mold thereafter. Propeller machining process. Cut off the cast gate, riser, the hub of both ends and shaft hole processing. Insert the hole within the keyway, scraping the shaft hole. Processing the blade of the page of the leaf back for the balance experiment. When the processing of the first two ends of the hub of the riser, gate and other spare parts, causing the hub before and after the two datums, and then boring along the center of the hub and hole in the hole slot. Boring can be carried out in the lathe or boring machine. Some large-scale paddle can also use self-made vertical or horizontal boring raw processing. Processing will generally prepare the model or sample axis to check the processing quality. Blade processing. According to the propeller measurement, to draw the outline of the blade line, chisel off the excess part, and then the leaves the back of the processing. The processing of leaves is based on foliage as a reference plane. After the leaf processing with it as a reference plane, remeasure the thickness of the blade, and according to the requirements of the drawings to determine the thickness of the metal layer from the back of the blade, the first drilling depth of the metal layer thickness, the depth of the hole, scoop out the facet shape curve, and then remove the excess metal layer along the blade. Propeller packing. The propeller edges are protected by corrugating paperboard. Then the whole propeller body will wrap by plastic membrane and placed safely into plywood case to avoid any surface damage or corrosion in long-distance transportation.
Perfect.
Haben wir eins da? Und den Fahrzeug? Also,